Assalamu alaikum wa rahmatullahi wa barakatuhu. Friends, welcome back to my channel. In this session, we will discuss this classic collection to Samsung microwave oven. We will perform complete troubleshooting with the help of circuit diagram, and we will see the most common faults, their reason, their solution. We will continue step by step, and we will study the wiring diagram. Basically, it is a question from my viewer. He asked me to explain the circuit diagram and troubleshooting procedure. Let's locate its main components. Input power cable, that is here. Then this is primary fuse. Thermal cutout, controller board, door interlock switches here, high voltage transformer, high voltage capacitor, high voltage diode, blower motor, magnetron. Then this wire, it is going to the microwave lamp and turntable motor that is under this oven body. If you don't have good practical experience in power electronics, never try to repair, because it have unisolated live voltage and it have high voltage. A very small carelessness can lead us to death. There is no chance in this section. So we must take special care. We need to discharge this high voltage capacitor. Before touching to this device, this circuit, before starting troubleshooting, if you have high voltage discharging kit, you can discharge it. Use this discharging kit. During this troubleshooting procedure, whenever we will apply power, after removing power, we will discharge it, and it must be ensured. Connect to capacitor second end. Both terminals discharge must one by one, and for more safety, connect between both terminals. For extra layer of safety, use a long nose plier with a good insulation on the grip. Connect between both terminals of the capacitor. Discharge it. Now the first fault, that this microwave oven is dead. It don't have any display on the controller. Line, neutral. Line from the fuse is coming to this control board. This is connector that is connected to low voltage transformer. Then neutral through this thermal cutout that is on magnetron here. After cutout, it is coming here. Control board. If control board don't have any display, this microwave oven will dead. If it is not receiving power supply, or there is problem in this control board, the system will remain dead. If there is no power reaching at this connector, might be the fuse is open, might be this thermal cutout is damaged, or the cable is open circuit. Set multimeter to continuity. Connect to one wire, one lead of input terminal, and connect to fuse one end. If it is giving continuity here, that means from this point to this point the cable is good. Now check to second side. If it is giving continuity, that means this fuse is good. If it is giving continuity here, it is not giving continuity here, the fuse is open. We can also verify fuse in this way. Now we can check at this connector. This is power connector for this board. Yes, it is giving continuity here. if the fuse is open, fuse is damaged, it will not give continuity here. That means from this point to this point continuity is good. Now we can check second side. Connect to second wire, and here is this line. Check here. One side it is giving okay, second side it must provide continuity. It is reaching here, and same way it is reaching at this point. So this board is receiving power. Now check the earthing wire. This is the most important point. Connect to this earthing wire and connect here. It must be connected. If voltage are reaching here, it will turn on. It have its transformer and microcontroller. That time it must give display. Now I applied power. We will receive power here at input terminal, and we will receive power at this connector of the board. It is reaching 117 volt. That means the power line is good. If it is receiving power at this connector and it is not giving display, that time low voltage transformer. Then we have here capacitor, -5 volt regulators, microcontroller, display. That time we have problem in the display. When it will receive power, receive line voltage, it must turn on. Now the second condition, when we apply power, the main circuit breaker trips off. That is due to short circuit. Might be from this point to this point, this cable is short circuit internally. Its internal insulation is perished, and its metallic connector, metallic wires are touching together. It can cause to trip out the fuse. At that time we need to replace this wire. In some conditions the fuse is good, thermal cutout is good, but our input circuit breaker is lower than this fuse amperage. At that time circuit breaker will trip off, fuse will remain safe. That time we have short circuit in this main board. As we diagnosed in last video that this MOV, it was short circuited. This transformer may be short circuit, so we need to verify the short circuit condition. At that time we can remove from this point and we can check continuity between both wires. If the continuity remains constant, that time this wire is short circuit internally. We will replace it. How we can verify thermal cutout? In continuity mode, apply some heat. It is open. It will remain high until its temperature is high. When the temperature will return back to normal, it will make the circuit again. This is its good working condition. When the temperature will increase, it will turn off for the time. We can see it started again. In some microwave ovens, we will find this board. This is EMI filter. Line and neutral enters here, then fuse, then this parallel line, capacitor, inductor. Current will pass through this inductor and it will enter to the microwave oven. If we replace fuse and fuse burns out again, this capacitor must be checked. And if current is not passing here, at that time we will check continuity of this inductor. In this microwave oven there is an additional safety. It have main relay. In normal microwave ovens there is just only one relay, that is for high voltage transformer. But here is main relay in this controller board. it is using two relays here. When this switch is closed, when the door is opened, at that time it will provide continuity at these 2 points. When the door is closed, it will remain open. When the door is opened, it will provide continuity. When it will provide continuity, it will give interlock that door is opened. When door is opened, at that time it will turn on this relay. When this relay will turn on, these voltage will reach here and it will go to the lamp. This is from thermal cutout direct to the lamp, and this switch will ensure that door is opened and it will force to remain off this relay. It will not allow microcontroller to turn on this relay so that this transformer will not receive voltage. And there is another door interlock monitor, that is this switch, and this switch must be open if due to any reason, if this switch is short circuited, at that time this switch will make short circuit and it will not allow to turn on high voltage transformer because door is opened. At that time it will blow the fuse or it will trip the circuit breaker. Door is opened, this switch will open so that the supply will not pass to this side. But at that time, for an additional safety, there is another interlock monitor. It will allow short circuit between motor, fan and this transformer. So it is extra layer of safety here. Now I applied power. The display is turned on. Now when we open the door, this relay is turned on and the lamp must glow. If the lamp is not turning on, we can check the supply on the lamp. Might be the lamp is damaged or relay is damaged. So we can verify up to these 2 points. Set multimeter to AC voltage. When the door is opened, it will provide 115 volt, 120 volt at the lamp. When door is closed, the relay will turn off and voltage will not appear. When the door is opened, the relay will turn on and voltage will reach here. Now I removed both points from here and here, input points of this transformer, that is from input side. So I disconnected the high volt section. I will check AC voltage on these points. Now I will turn on microwave oven. We will check voltage here and we will start any cooking profile. We can see it is receiving 115 volt here at these 2 points. I turned on for 1 minute, so this microcontroller will provide 116 volt, 120 volt, and it will ensure that this door is closed. If I will open the door, immediately it will cut the power. Why? This switch will open, this switch will open, this switch will open. Now when the cooking profile 1 minute is finished, it turned off this relay, it disconnected power to the transformer, to the fan, to the turntable motor and to the lamp, because this relay is also turned off. This relay will turn on when we will open the door. If it is not providing voltage here at this point, what we can do? We can see we have two relays here. This is primary and this is power relay. These switches, door switches, 1, 2, 3, 4. These switches are here. When the door hinge will come here, it will press this switch. When we will close the door, this hinge, it will enter here in this entrance, and here it will press this lever, and it will press this lever of this switch. When it will press this switch, it will give continuity, so it will make circuit. If it is not giving continuity, at that time we can verify the proper operation of the switch, and we can check its position so that it must open or close the circuit. So we can adjust its position so that it must provide continuity. So this switch is in the path of the high voltage transformer and the relay. When the relay will turn on and door will close, at that time it will pass the voltage. That is this switch. Same way we can check these switches. Here we have two switches. This switch is safety switch to turn on, turn off the operation of the microcontroller. This is separate switch. We can remove them easily. Just only open this plastic lock in this way and this switch. So we can replace it very simply, very easily. We have another switch here. Two switches with one lever. And here, when the door is locked, it will press this switch and it will make this circuit. Same way we can check continuity. We can see this line is coming here. When this switch is closed, then it will pass to the relay. Same way we can verify this switch here. Now we will check high voltage transformer section. We will discharge it. For more surety, we will discharge with plier. Now set multimeter to resistance. In the transformer primary winding, it will give less than 1 ohm because it is 110 volt transformer. 0.5, 0.4, 1 ohm, like that. Check between chassis, it must be open. It will not give any resistance between chassis. Now connect this thin wire, that is 3.3 volt, and this wire. Connect between these two wires. It will give low resistance. But we will check with chassis. It will give open circuit. Now we will check with this winding, that is the thick wire. It is high voltage wire, so it is 111 ohms. Now discharge high voltage capacitor. Again set multimeter to capacitor. Connect across both terminals. It is 762 nanofarad. It will around 1 microfarad. So it is a little bit weak. Set multimeter to resistance. Now we will verify the magnetron. Connect between these two terminals. It will give low resistance, less than 1 ohm. Check between chassis. It must provide high resistance. Check input terminal and chassis. It must high. Its body must connect with this body, that is connected with transformer, because transformer one end of this high voltage wire is connected to ground, so it must be connected to chassis. Now if we want to test this high voltage diode, we cannot test it using multimeter in diode mode because its drop voltage are more than this. For that purpose we will use 12 volt power supply or 9 volt power supply. You can use 9 volt battery as well. Negative end of the supply is grounded, and we will connect positive of the supply to this multimeter positive lead, and we will connect black lead to the open end of the diode. It is giving 9.5 volt, 9.6 volt. That means this diode is good. If it is giving continuity, that means that diode is short circuit. But this time this diode is good condition. If it is not providing voltage, that time the diode is open circuit. Now let's pack it up. First we will connect this diode. Then this wire to the capacitor. This wire which is connected to the diode end, it will reach to this magnetron, and transformer low voltage wire will also reach magnetron this point. Now this is AC input terminal of this transformer. We will connect here. This AC input terminal will reach here, line and neutral. Now door switch here. This wire now this connector here, these black wires will come to this relay, white wires will come to this relay, door switch here. It is a best practice to check voltage first, that the cooking profile is starting. Set multimeter to AC, and now I will apply power. When the door is opened, no voltage will reach at multimeter and lamp must turn on. When I will close the door, the lamp must turn off. No voltage there. Now I will set cooking profile. The voltage are reaching here. When I started cooking profile, at that time this line is now clear. This relay is turning on. That means this circuit is now okay. Voltage are reaching at high voltage transformer, which we removed the connector, and this side is also okay. From this point, drive motor, that is turntable, and lamp and blower motor, the fan, these are working good. We can see it is providing power for high voltage transformer. Fan is running, motor is turning, lamp is on. Now I will connect these wires to the high voltage transformer. First we will measure AC voltage, that is the output of this transformer, high voltage transformer. AC voltage. Now I connected one wire to the chassis and one wire to the AC output terminal, that is high voltage section. Now I will provide 1 minute cooking profile and we will check voltage. It is 2.051. Now we see 2.05. That means 2050 volt AC are coming out from this transformer. Now we will set to DC. I will connect to the upper terminal where the diode is connected. Set multimeter to DC. And now I will check the voltage at high voltage capacitor. 2.87, approximately 3000 volt, and then it is coming to 1600 volt. This time the magnetron is working properly. So in this way we can verify the function. Now let's discuss the common faults in the microwave oven. First, the system is not turning on. At that time we can check power cable, fuse, thermal cutout and controller board. Because this microwave, it have primary power relay, main power relay, that is directly involved in the turning on power. If this switch is not working, it will not provide interlock to turn on primary power, so the lamp will not start, even the door is opened, maybe the wiring harness. These are the basic things related with this fault. The second thing, it is not responding to keyboard. At that time we can verify this keyboard strap here. If it is not working, at that time we need to replace this membrane touchpad, that is front keypad. Then the next fault, the most common failure, that we close the door, we select cooking profile, we apply timer, countdown timer starts, but it does not start cooking. There is no heat. There are many reasons for this. If these switches are misaligned or switch is malfunctioned, at that time it will not provide voltage at these 2 points. The same way we tested the voltage, so we can remove these connectors and we can test voltage. Just close the door, select timer, apply voltage, multimeter will show the voltage. If it is not showing the voltage, at that time we can follow the diagram. The same way, in the diagram there is key noted that at opened position, when the door is opened, what will the position of the switch. So we can follow that guidelines, how the circuit is working. Then if it is not heating up, might be this power transformer, high voltage transformer, this diode is bad. It is also will be a reason, so that it will not provide high voltage to magnetron, and if the high voltage capacitor is damaged, it will not provide voltage. If the diode is short circuited, it will make overload and it will cause to burn out the fuse. If this capacitor is short circuit, it will also cause to trip the fuse. So if we see the circuit, might be this secondary interlock, primary interlock, these interlocks, and this power relay, that is the inner side relay. In this side, closer to transformer, this relay is bad. In normal microwave ovens, Korean microwave ovens, Daewoo and LG, like that, there is just only one magnetron relay, that is this power relay, and one relay that is for lamp and turntable. But here it have two relays. If the circuit is good, that time might be this relay is not making connection. This will be a reason. And if magnetron is bad, it will not produce heat. If the turntable is not moving, it is not rotating, at that time we can check power at this connector. It must be 120 volt, and if the power is reaching here and it is not turning, we can test the motor, we can replace the motor. Just only in the bottom side there are 4 screws. Remove it, replace it. If the lamp, fan and turntable are not moving, we can check wiring, because these are connected in parallel with this transformer. The next fault, when we provide programmer, the counter will not start. At that time this switch, it is not making open, it must be open. In this brand Samsung, when the door will closed, it must be open circuit. If this switch is not making open contacts, At that time it will not start counter, and in some conditions we feel like sparks and heavy sound. Most of the time this power transformer, high voltage transformer, it makes sparking. When it makes sparking, it will make sparks and it will make heavy sounds. And sometimes there is sparking inside this microwave oven. If there is sparking in microwave oven, at that time we can replace the ceramic paper inside this body that is in front of the magnetron antenna. That is ceramic paper. Sometimes there is uneven cooking, that is due to turntable. And another fault, when it is cooking, it will stop while cooking. At that time this fan is not spinning at full speed. Might be there is some obstruction, there is something wrong, or the duct of the heatsink that is closed. So we can check it. We can check the duct here for air circulation. If it has something wrong, we must clear it. If this motor is bad, we can replace it or repair it. I hope this video is informative. If it is informative, hit the like button. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.